saw De Moivre's theorem before?
Depends.
Okay. De Moivre's theorem was very simple, and it just said multiply the R1 and R2, and then, remember?
Yeah.
Really, really simple. This, for those of you who might have forgotten what cis is, remember with normal coordinates you have polar in this form, but if they are complex numbers, for real numbers, for complex. For complex, you have the magnitude, I'll call it R, and you have cis angle. So instead of using the angle symbol, you use the cis, okay? And the cis is cosine plus I sine. There is your I, and that's why it's complex, okay? When you have the other one's rectangular, with real numbers, you have, let's say, a I plus B J with a hat, right? With this one, you have A plus B I, right? With complex. Just to make an analogy so that you can remember, okay? So, what are we going to learn now? May I erase this? No. That's like a summary of 3 different lessons, but it's there if you need it. So what you're going to learn today that is different is De Moivre went one step further and he said R to the will equal R to the n, cis to the n. Okay. So may I erase now?
Yes, I just have the orange. Or
Yeah, because I just wrote that. So for example, if I have 2 cis,
oh god.
what will that be? It will be 2 to the 5, 5 times 30. So it's 2 to the 5 is 460 times 2, 32. 32 cis 150, okay? Of course, this would be way too simple, right? So, they're going to give you, for example, use De Moivre's theorem to find 1 plus I to the 3. Oh, to the 13, even better. So what do you have to do first? Is this in rectangular or polar?
Rectangular.
Rectangular. And you need, the De Moivre's theorem works when it is in polar. So you have to go from rectangular to polar. It's easy. How do you go from rectangular to polar? You graph. This is X and this is Y. So I've got 1 in X and 1 in I. How do I know it's 1 in I? There's only an I. It's got a 1 in front of it that you can't see, but it's there. So 1 and 1, just by looking at that, how much is the angle?
45.
It's got to be 45. And how much is this?
2.
Square root of 2. There, you converted it. So this goes and it is square root of 2 cis 45 degrees. And now you can raise it to the 13. Okay? Really, really, really easy. So you've got square root of 2 raised to the 13 cis 13 times 45. Okay? Simple, right? And then you have to change it back to rectangular once you have it. Okay? How do you change it back? You graph it in to see what quadrant it's in. Is that clear? Do you want me to do it? Or
Yes.
you good? You want me to do it? Fine. So let's finish it. How much is square root of 2 to the 13? That's 2 times 2 times 2. It's 2 to the 6 square root of 2, right? So 64 square root of 2, correct? And then say,
90.
how much is 45 times 13?
585.
500?
85.
Okay, so if I graph this, where's it gonna be? Let's see.
Left.
It's gonna be 585 is 360, and then I have 225, right? So it's, this is a, here. 64 square root of 2. So this one here, because it's 45 degrees, I know that this one's gonna be 64, and this one's gonna be 64. How do I know that?
Because it's
Because similar triangles, one square root of 2, right? So this one is going to be 64 minus 64 I minus 64 J. And that's my answer. Okay? Now, the next part is this. Roots of complex numbers. Now, with roots, what happens with roots? When you have, let's say that x to the 3 plus 2x equals 8, for example, how many roots am I going to have here? How many solutions am I going to have? 3. How do I know? Because I have a little 3 here. The exponent tells me how many roots I'm going to get. Just like when you have this, you know that there's going to be 2 roots, plus and minus 2, right? So, if they tell me to find, for example, a 16 cis, 60 degrees, and they want me to find the 4 fourth roots. Why do I know there's going to be 4? Because they're asking for the 4th roots. So that's why there's going to be 4.
16 to the power of 1/4.
Yes. So this is going to be 16 to the power of 1/4. Cis 1/4 times 60, right? And that gives you 2. 15. Ah, but it doesn't stop there. That's just one of the 4 that you need. So how do you find the other 3? You put the original one. And then you go. The next time is going to be 360. Let's see. Yeah. So you're going to start. The next one is going to be 2 cis, and I'm going to put 15 plus. Since it's 4th roots, I'm going to take 360 and I'm going to divide it by 4. The next one, I don't know how much this is. Can you tell me how much this is? Please?
105.
Huh?
105.
105? So this, oh, the total is 105. Okay, so this one's going to be 105 plus.
No, wait, that means total equals 105. 360 divided by 4 is 90 plus 15 is 105.
That's good.
So why are you putting the same? Never mind.
Va pues, let me do it a different way. 15 plus 360 divided by 4 plus 360 divided by 4. Bye. And then the last one's gonna be, guess what?
195.
15 plus I'm doing it this way. I could put times 3, but I want you to see that for the fourth one, you have to add the 360 divided by 4 3 times.
Why 3 times?
Because we have to find 4 of them.
Why not 4?
Let's say that this
Why not 4 of 3?
because we need, since it's to the fourth, how many fourth roots are there? 4. So I have 1, 2, 3, 4. If this were the 6th root, like here, well then I do everything to the 6th, to the 6th. This would be divided by 6, and then I have to find 6, and all of this would be divided by 6. And I have to go to more. This would be times 4, right? Now I'm making it shorter just because I don't want to write so much. 6, 15, 5, 360 divided by 6. Is that clear?